Hello. Today we are working on a lesson that is a bunch of review pieces mixed together. These problems have a pretty simple concept, but because they have fractions, it's easy to make a mistake, especially if we add positive and negative fractions. Those just cause people issues, but they're very important. So we are combining like terms, just like we've been doing the last couple of weeks. We're adding some fractions. I kept the assignment fairly small so that way you can really focus on double checking your work. So we have three main goals. Goal one, be able to combine like terms by adding, subtracting, multiplying, and dividing fractions. So all things that you have done in the past, but still important. Number two, be able to simplify fractions. After you have a final answer, fractions need to be simplified to have the perfect answer for full credit. And goal three, understand different ways a fraction can be paired with a variable. We're going to go through a couple different examples of that. We just don't want you to encounter something that is simple, but because it looks a little different, you get a little confused by. So we will dive into a small number of notes, get through these examples, and give you time to work. So we are going to be looking at terms that look like this. In this case, we have 3/8 of x, or 3/8 x, and it's important to know that that is the same thing as 3x over 8, because we know that multiplication and divisions are opposite. So if we have a 3/8 and we multiply it by a number, that's going to have the same result as multiplying 3 times x here, or here, or somewhere. I'm just trying to draw a little line. There we go. 3 times x, and then dividing by 8. So even though these look very different, we are going to realize those are the same things. In reality, the 3/8 x is the same as 3/8 times x over 1, and the 3x over 8 is the same thing as 3 times x over 8, because we know that 8 times 1 and 8 are the same thing. So you're going to see the fractions paired with variables in both ways, but they're really the same thing. One other example, when our variable is paired with a 1, that means we really have three ways that we could write this. Of course, x over 20 is the same as 1x over 20, because if there is just a variable by itself, that implies that there is one of them. And similar to the example above, 1/20th x, that would be the same as 1 over 20 multiplied by x over 1, which is the same as 1 over 20 times x. So these three examples have the same value. Okay, so a couple examples here. We might have to add some fractions together. Here we have 3/5 x plus x over 8, which we know is going to be the same as 3/5 x plus 1/8 x. And we notice that these have like terms, so we can add them together. So we need to add up 3/5 to 1/8 by finding a common denominator and adding. So I know my common denominator is 40. So I multiply the 3 and the 5 by 8, and I'm going to multiply the 1 and the 8 by 5. Don't forget my x here, at least don't forget them at the end. Now I can add these up, and I would end up with 29/40 x. So basically just adding fractions, however, the variable's attached, so I had the variable at the end. Similar idea here. We have 2/3 of x, but we're multiplying it by 3/4. Notice that there's not a second x here because that would bring us to exponents. So we're just going to be multiplying fractions. We're going to be doing 3/4 times 2/3. Remember, you don't need a common denominator. You're going to be doing the top times the top and the bottom times the bottom and simplifying and adding your variable. So same rules for adding, subtracting, multiplying, and dividing as usual, but the variable is going to be there. And you can only choose to add and subtract things that have like terms. All right, so we have some examples. Number one, if you want to pause this and try it on your own, that's fine. If you just want to watch me methodically work my way through these problems, that's fine. I think we have 3 examples. So here, 3r over 5 plus 4/15 r. We're just going to find a common denominator and add. So I know that'll turn into 9/15 r plus 4/15 r. And when we add them up, we have 13/15 r. It's important to know that we don't add the r's together. We don't end up with 2r. Just like if you had 5 apples and then you bought 7 more apples, you don't have 12 apples. That label is just going to stay the same when you're adding or subtracting. All right, number 2, this has the distributive property. So we're going to be multiplying the 2/5 by 3/4 c and the 2/5 by -5. So I'm going to be doing 2 times 3, which is 6, 5 times 4, which is 20, and that has a c next to it. And then 2 times -5 is -10, right? -10. And 5 times 1 is 1, or 5. Can't do basic math. And now I need to simplify, so that's going to end up being 3/10 c minus 2. And last example, this is the tougher format, even though there aren't any new steps, it's just because there's fractions. Going to distribute, I'm going to distribute both here and here, here and here. 1/3 times h is just 1/3 h plus 3/12, I'll simplify that later, minus 2/3 h plus 8/15. Remember, a negative multiplied by a negative gives us that positive 8/15. So now I am to a point where I need to combine like terms. So I'm going to combine 1/3 h and a negative 2/3 h. Luckily, we already have a common denominator, so that's going to turn into negative 1/3 h. Then I'm going to be adding, in this case, 3/12. I can think of that as 3/12 or 1/4 plus 8/15. My common denominator here is going to be 60. So I'm going to multiply both of these by 5. I have 15/60. I have 32/60 here multiplied by 4. They're both positive, so when I add them together, I get plus 47/60. And I've combined all the terms I need to, and that is that. I think you'll do well with this assignment. Just be careful to double check all of your fractions and your simplifying. I think you'll do well. Good luck.